right? The atom or group of atoms give a molecule its what we call functionality. Right? What that word functionality means is how it reacts, right? What the physical properties are. Right? What it's like in its lowest energy state. All of that is a all of those things are consequences of its functionality or what functional groups are present. Right? Some things like alkanes, we talked, that's the very first thing that was in the video. You've seen this before too, multiple times. Like alkanes are, they are a type of functional group, and they don't really have any other characteristics other than carbon hydrogen single bonds. Right? But beyond alkanes, there are multiple types of functional groups. And so we're going to talk about that. We're going to talk about different types of functional groups and their polarity and how they affect reactivity and things like that. So the best teacher is something like a molecule like this, where you have a bunch of different functional groups present, right? But really, they're really only a few, right? It looks like a lot, but there are really like multiple of the same type of functional groups present in Paxlovid. And the reason this is important is because it's the functional groups in a molecule like this that has biological properties. The functional groups define its biological properties. They define like what it binds to in the cell, what it, if it's playing a role in apoptosis or cell death, what's the mechanism of cell death. All of that is defined by the functional groups, right? So I want to start out with something very basic, right here. So this functional group, there's a carbon at the end of this. It's a C triple bond N. Is what we call a nitrile. All right. And for functional groups, let me just say up front, I'm not a champion of memorizing, but I do realize that some things are the best way to learn them is to memorize them. So I'm not, for functional groups, my suggestion is to make you a set of flashcards, or you can download a set of flashcards in the App Store. I think there's and I think it's in the syllabus, there's an app called Organic Chemistry, or the Organic Chemistry app, or Organic Chemistry Reactions, something like that. It has all the functional groups in it. There's a flashcard app with the functional groups. So my suggestion would be to download something like that, or you can Google a list of functional groups, print it and paste it somewhere, or you can use your book. There's a list of functional groups in the book. But I'm just going to go through some of the more common functional groups that you'll see a lot of. And then we're going to go from there. And then from there, we'll transition into talking about resonance, because resonance is also a consequence of what functional groups are present. All right. So that C triple bond N is a nitrile. All right. There's another functional group here. C double bond O, we call that simply a carbonyl, right? If it's just C double bond O, it's a carbonyl, but carbonyls change based on what's bonded to them, right? So you can see this carbonyl has and I'm not going to the other side because this is what defines it right here. Oh, sorry. This carbonyl is bonded to a nitrogen, right? So it's actually C, come on, Russell. C double bond O N H, and I'm going to put an R here. This is a generic. R can be any generic group, so I'm going to put an R there. And then it also has a bond on this side to carbon, right? Because this is a carbon right here. This particular type of carbonyl is called an amide, AMIDE, right? The AMI part is related to the nitrogen, because nitrogen containing compounds are called amines. So a nitrogen that's bonded to a carbonyl, we call it an amide, right? If you look in this molecule, there are multiple amides present. There's one here. There's one here. There's one here. So you really have, like I said, it looks like a lot of functional groups, but really, they're not a whole bunch because the amides make up most of this molecule. All right. If you look here, right, that's 3 carbons. Is that right? The end of every line is a CH3. So this is a those are 3 CH3s. What we call this group is a tertiary butyl group, right? Tert butyl. I'll explain what the butyl part comes from and all that. But it's actually, the generic name for it is an alkyl group because it's all carbons and hydrogens, right? So it's an alkyl group, but the specific name is a tert butyl. It's a tert butyl because there's a carbon here. All right, so how many carbons is that total? 1, 2, 3, 4. Is that right? Right, and then we call it, so 4 is the same number of carbons that it as butane. So then we call it butyl because we had to change the ending. If it's a substituent, you're going to change anytime any alkyl substituent, you're going to change that ending to YL. So methyl, ethyl, propyl, butyl, so on and so forth. I think that was in the skeletal and line forms video that I sent you. All right. So it's the butane, the butyl part comes from the 4 carbons. The tert part the tertiary part comes from this carbon right here, right? When we have, anytime you have a carbon, carbons can be, all right, I'll go ahead and discuss this now. You can have a primary carbon, a secondary carbon, or a tertiary carbon, and you can have, oh, shit, hold up. Sorry about that. So your carbon can have has different what we call bond orders, right? So you have methyl, primary, secondary, and tertiary. A methyl carbon just looks like this, right? CH3, right? Nothing else bonded to it. A primary carbon is going to have 1 carbon bonded to it, right? A secondary carbon is going to have 2 carbons bonded to it. And then a tertiary, what do you think? Just logically, what is a tertiary carbon going to have? How many carbons?
3.
3 carbons bonded to it, like this one, right? So tertiary is like the one we have shown below, but we'll have a carbon and it's going to have 3 carbons bonded to it. So this is called a tertiary butyl because that center carbon has 3 carbons bound to it. So that's why we call it a tert butyl group or tertiary butyl group. And let me write out the so this is primary, secondary, and tertiary. All right, any questions about that so far? So carbon can be, you can have a methyl carbon, a primary, a secondary, and a tertiary. And then that's important also when we start talking about if carbon has a charge, right? But I'm not going to get into that like right now. But you'll see this again a lot. So primary, methyl, primary, secondary, and tertiary. You'll see that a lot. But the tert butyl is tertiary butyl because it's a tertiary carbon, and then that carbon is bound to 3 other carbons. And with it being the 4th, it's what you call an isomer of butane. So it's tertiary butyl. All right. Let's go to here. We call that an alkyl halide. Alkyl because of the carbon, halide because of the fluorines attached to it, right? Fluorines are in group 7 on the periodic table. So those are halogens. And so we call something like this that has alkyl groups and halogen groups together in the same molecule, we call it an alkyl halide. Specifically, this is what we call a trifluoro methyl group. Right, you're going to see that again as well, right? That's the specific name for it, but in general, it is an alkyl halide. It has an alkyl chain, and then it has halogens attached to it. All right, questions? Any questions about anything? All right, let's go here and let's look at this 3-member ring right here because that'll give us a chance to talk about that. How many carbons is what's the term we use for 3 carbons? Anybody? It's propane, right? So if you have a 3-carbon chain, like so, we call it a propane. But carbon can also cyclize, right? You can have, as you can see, you got carbon, cyclic carbons here, right? That's a carbon ring. This contains a nitrogen, but it's still mostly carbon. That's a ring right there. So carbon can also cyclize. If you have a 3-carbon ring, not chain, and there's a convention that we use to describe that. All right, we call it a cyclopropane. In this case, there's some really cool reactions that you can do to make cyclopropanes too. Most of the time, you'll take an alkene and then you do a cyclization. You know, like there's a bunch of reactions. You can do a Simmons-Smith, you can do diazo chemistry on it. But the point is, these rings are not that difficult to make. Right. So if you have a 3-member ring like this, 3 carbons, propane is the parent, and then the cyclo part as the prefix means that it's a ring and not a chain. All right, questions? Any questions? So we've seen carbonyls, amides, alkyl halides, cyclopropanes, nitriles, right? There are a bunch of different types of functional groups in organic. My suggestion again is to make either a list or make some flashcards so you can remember them. All right. Questions? Any questions? All right, let's go to let's look at aspirin. Because aspirin has some really common functional groups. What do you see right away? Present there in aspirin. Anybody? Something that we just saw.
Carbonyl.
Carbonyl, right? And but again, remember every carbonyl is defined by what is bonded, what's bonded to that carbonyl carbon. So in this case, you have a hydroxyl group like this. This is called a, I think I told y'all this when we were doing lab the other day. It's called a carboxylic acid, right? Carboxylic acid. Those are very, very important functional groups, right? We got another carbonyl right here, don't we? This is different. The oxygen is not an OH, right? That oxygen that's bonded to your carbonyl is bonded to a carbon on the other side. So this is in the same family as a carboxylic acid, but this is what we call an ester. Right, so the typical ester would look like this, right? So there will be a carbon attached to your oxygen here. So this is what we call an ester. So carboxylic acids and esters are really in the same class of compounds. You can actually take esters and turn them back into acids, or you can take acids and turn them into esters. There's a few types of reactions that you can use to do that. But the difference in the ester and the acid is what's bonded here to the oxygen, right? For a carboxylic acid, it's OH. For ester, it's OC. All right. What about here? We got another very important functional group that you'll see a lot.
Thrown out. No.
All right. That particular functional group is what we call an aromatic. There are a lot, that is really a generic name. There are a bunch of different types of aromatics, but in general, when you see a functional group like this, we call it an aromatic. If you'll notice, it has alternating double and single bonds, right? You can see that you have a double bond here. You have a single bond here. You have another double bond here. So all the way around that ring, right? And it's cyclic. All aromatics are cyclic. Right? A compound can't be considered aromatic if it's not cyclic. All right, let's look down here. What is this one again?
The carboxylic acid.
Good, carboxylic acid. What about this one? You're going to see a lot of this, by the way, especially in part 2. Aromatics have their own special set of reactions that they do, everything. Now we actually talked about this when we were doing lab either Tuesday or Wednesday. What is that functional group?
Alcohol.
Alcohol. Good. Right. So again, it's the functional groups that give things their reactivity. That alcohol and salicylic acid is what allows us to react salicylic acid with acetic anhydride to get aspirin. Without that, you couldn't do that. So the functional groups give molecules their reactivity, their functionality, their physical properties, their chemical properties, everything. Over here, we said that this was acetic anhydride. What type of functional group is the anhydride? What do you see? Let's just go from here. What do you think? Anybody?
Does that count as an ester?
It is. That's very good. And anhydride is a type of ester, right? It's a specific type of ester. So we call it an anhydride. This type of ester has a oxygen linkage here between the two carbonyls, right? There's some other functional groups we're going to touch. So, but these are like the main ones, the ones that you definitely need to know. No matter if you finish organic and don't know what an ester or a carboxylic acid or alcohol is, then you got to do it over. You need to get a do-over on that. All right, let's go down here to THC. I was reading an article this morning. They're talking about federally decriminalizing marijuana. They've been saying that forever. All right. So everybody, well, maybe not, but you probably have heard of THC. You know what it is. It is it's the principal component in marijuana. It's the hallucinogenic part, or the hallucinogenic compound that's found in marijuana. But forget about that part. We have a lot of functional groups here that we can identify, right? The first is, let's start with the ones we already know, right? What about here?
Alcohol.
It's alcohol. Good. And here. What about here?
Aromatic.
It's aromatic. Excellent. What about here? What do you call it?
Alkane.
Say that again.
Alkane.
It's an alkane. You're absolutely right. But because it's attached to a larger molecule, so it's a substituent on a larger molecule, we're going to call it an alkyl. So alkyl group. All right. Does that make sense? But you're right. It isn't. If it was by itself, it would be an alkane. All right. What about, this is one we haven't talked about, but you've seen it before. What about here?
Alkene.
Good. Excellent. It's an alkene. That's the way we describe compounds that contain double bonds, is we call them alkenes. The ene on the end tells me that there's a double bond present. All right, good. Okay, we got one more that I want us to be able to identify, and that's here. You have an oxygen, and on either side of that oxygen, you have a carbon. So the basic structure is like that. Anybody if you watched one of the videos, I think it was the first or the second one I sent, you should have seen this already, but if not, that's okay too. But does anybody know what that functional group is right there?
And ether.
Excellent. It's called an ether, right? It's the same. I don't know. Well, I don't know if you've ever seen a movie or a television show where you see somebody sneak up on a person and with a little napkin and put it over their face and put them to sleep. Normally, that what's on that napkin is dimethyl ether, which looks like this, or diethyl ether. Sorry about that, which is CH2, CH3 on one side, and then CH2, CH3 on the other side. So this is diethyl ether, which is the most common ether in organic. Like you can use it a lot for solvents and things like that. Or again, you can put it on a handkerchief and but you didn't hear that from me. And then this is dimethyl ether, right? So THC has a lot of it. It's a multifunctional molecule. But again, all of these functional groups matter. If you notice the backbone, there are 3 rings in the backbone right here. So you have a ring here, you got a ring here, and a ring here. That gives THC a specific shape. Also, if you notice the stereochemistry here, or the 3D orientation, right? That H that's on a dashed line over here is going back into the page. The one on the wedge line on this side is coming out of the page. So THC actually has a specific shape. And that shape plus the functional groups allow it to bind to those cannabinoid receptors in our body, right? That's on purpose, right? All the different functional groups that are present, and then the shapes, the actual shape of the molecule, which is kind of separate from the functionality, but it's a consequence of the functionality, because those rings fused together like that are going to give this molecule a specific shape or stereochemistry. So that means it's going to fit into that receptor like it's supposed to. All right. If you look at the other molecule down here, I'm going to put it up on this page so we can look at them side by side. All right, there are a couple of differences, not a whole lot, but those differences that's the difference in being high and not being high. All right, the THC is, again, that's the euphoric compound that's in marijuana. So if you use marijuana, I'm not advocating that, but if you use it, that's what causes those euphoric feelings. Down here, this is a CBD molecule, right? Let's compare them and look at the different functional groups. So this is the same, is that right? The alcohol is the same. The aromatic is the same. But look at the structure now, right? This part of it is the same. What do you notice that's different?
The ether.
The extra alcohol.
It's got another alcohol. Good. I heard somebody say something about the ether too. The ether is broken. It's broken, isn't it?
Yes.
It's like the ring where the ether is up here got popped open, and now that oxygen became an OH group. And then the 2 methyl groups that were here, we didn't really talk about them. One of those methyl groups, it looks like that was some type of elimination to put a double bond there. You see, you got an alkene here now, and that ether, that CO bond got broken. Now, hopefully this kind of shed some light on the fact that the CBD, it may have some of the effects of THC, but not all of the effects, not the euphoric effects, because the structure is different and the functionality is different, right? Now you have a alkene here, right? Where up top, that was a cyclic ether, totally different. And you have an extra alcohol that you didn't have up top, right? let's see how many carbons are in the chain. Let's see. So we got 1, 2, 3, 4, 5 carbons here. So that is a pentyl group. Pent meaning 5, ill because it's attached. Let's see down here. What do we have? 1, 2, 3, 4, 5. So that's still a pentyl group. But are y'all following that? Do you see that how the differences in those molecules, right? Again, the functional groups give the molecule its functionality. And so when you change the functional groups, you change the functionality. And even with the CBD, the shape is going to be different. It's going to be slightly different because it's less rigid, right? You can actually, because this is now a single bond and it's not constrained by being in a ring like the bond up here. You can actually rotate around that bond. There are a lot of different things that can happen. And because of that, when this is ingested, it is not going to fit into, it may not fit into the same receptors the same way. It may fit into some different receptors in the body that THC might not fit into. So again, functional groups are important because they give molecules their functionality. They make the molecules what they are. It's like the molecules have a personality based on what the functional groups are. All right, questions? Any questions about that? All right, let me give you another nugget. Right, that's a 6 carbon ring. What's the prefix for 6? Anybody?
Hexa.
Okay, hex. Yep, hexa. All right. So we have a 6-membered or 6 carbon ring, right, with a double bond in it. So what prefix do I use again for rings? How do I differentiate between a ring and a chain? What's the prefix?
Cyclo.
Cyclo. Good. Y'all catching it. That just made my day. My whole Friday is made. Cyclo, right? So this is a cyclo. And then we said hex for 6. So cyclo meaning ring, hex meaning the number of carbons in the ring. And then there's an alkene in the ring. We said that up top that this was an alkene. Is that right? So it's this functional group is called a cyclohexene. Cyclo because it's a ring, hex because it's 6 carbons, and then ene because there's an alkene somewhere in that ring. All right, so we have an alkene down here too. You can see that there's a double bond there, so that's also an alkene, right? But this particular specific type of alkene is what we call a cyclohexene. 6-membered ring with a double bond somewhere in it. And it does not matter what location the double bond is. It doesn't matter where it is in the ring as long as it's there. If it's there, it's a cyclohexane. All right, questions? I'll be the first to tell you learning functional groups is kind of boring. That's why I try to use real stuff to teach it because it makes it relevant. All right, so we talked about quite a few: carboxylic acids, nitriles, alkyl groups, trifluoromethyl groups, amides. What we didn't talk about, we'll probably talk about on Monday. We'll talk about amines and a few other functional groups. But yeah, those videos that I sent you, just check them out. Those are some of that's when I first started doing the flipped classroom. So some of them are not that great. Definitely didn't have the tools to draw and stuff like I do now. But other than that, the information that's there is what's important. So, and some of them have music, some don't. I learned from trial and error. People would leave comments, turn the music off. Some people love the music, so I just did away with the music because, yeah, we learn from trial and error. So, but again, it's the information that's important. So make sure that you check them out when you get a chance. And there's also some other information in there about just different stuff, stuff that's practical. All right, any questions about anything? We're actually gonna stop early today because I don't want to start resonance without, with only 4 minutes